Hello students, today we'll do some numericals based on NLM and we'll try to learn the numerical problems based on NLM means we will learn about how to find out acceleration of bodies or we can say system of bodies when they are kept in contact or they are attached with pulley or other types of problem. So we'll try to learn to find out value of acceleration. Simply as we know acceleration is net force upon mass. So in every problem when we want to calculate acceleration just we have to calculate total force on the system and total mass of the system. Suppose I am starting from a example question 1. Suppose two objects mass m1 and m2 are kept on the surface and they are in contact. Suppose a force is applied on this. Okay, we are going to do some problems and in which we'll not consider the frictional force. Okay, now suppose there are two masses m1 and m2 and they are placed on the surface and they are in contact and force is applied on them. So we have to find out acceleration. As we know acceleration is simply net force upon net mass. Net force upon net mass. Now, what is the net force on the system? Simply, there is no friction, so net force is F and net mass. The system is of two masses m1 and m2, so acceleration m1 plus m2. So acceleration is m1 F by m1 plus m2. Next question, question 2. Suppose there are three blocks, one of m1, second m2 and m3. They are again placed in contact on a smooth horizontal surface that a force F is applied on them. So we have to find out the acceleration of all the blocks which will be common for all the blocks. So again net force, what is the net force? F. And what is the, as we know acceleration is always in the direction of force. So if we are applying force in this direction, so their acceleration will also be in this direction. So always when we are calculating the acceleration we have calculated the force which will be in the direction of acceleration, which should be in the direction of acceleration. So in this case since the force is applied in this direction, so acceleration will be net force F upon mass m1 plus m2 plus m3. Now next example, suppose there is a pulley and a string is connected on the pulley, one of m2, one of m1, and suppose m1 is greater than m2 and this string is massless string, so we can consider that tension through the string throughout the string which will be same because it is massless and there is no friction in the system. So again we have to find out the acceleration. So now as we know acceleration equals to net force upon net mass. Now there is no problem with mass because mass is simply m1 plus m2, but net force, as we know on this block m2 the net mg, the weight of this block will be downward m2g, and m1g it will also in the downward direction. Now since m1 is greater than m2, so we can consider acceleration of the string of this block will be downward and of this block in upward. Now net force of the system will be including m1g and m2g, but m1g is the force which is in the direction of acceleration, so we can consider it as positive, so m1g. But here m2g is the force which is in the opposite direction of acceleration, so here we can't consider it as positive, so we'll take it minus m2g. So simply acceleration is m1 minus m2 bracket g upon m1 plus m2. So This is the acceleration. Now let us take another example. Suppose there is a table and a pulley is connected on it and a string is passed. A string is passing over the pulley like this, and at the one end of the pulley M2 mass is connected, and here the another mass M1 is connected, and suppose this, its acceleration is in the downward direction, so its acceleration will be like this. Now again here all the string is massless, so tension can be considered throughout the string is same and there is no friction. Again we have to find out acceleration. So what is the method of calculating acceleration? We need net mass and net force. So there is no problem with net mass, it is simply m1 plus m2, but net force, and force should be in the direction of acceleration. So again here its weight m2g is in downward direction, here m1g is in downward direction. Here m2g is in the direction of acceleration, so we can consider it as plus m2g, but here m1g is in the perpendicular direction of acceleration. So we will when we take the component of m1g in the direction of acceleration, it will be 0 because m1g is in the perpendicular direction of acceleration, and when it is in the perpendicular direction, so component of m1g along the acceleration will be 0. So there is no component of this force along the direction of acceleration, so we can write it as 0. So net acceleration will be simply a equals to m2g upon net mass m1 plus m2. So simply when we are calculating the acceleration, we always assume, we always take the direction, we always take the force in the direction of acceleration. If it is not in the direction of acceleration, then we can take the component of that force along the direction of acceleration. And what is the process of taking component? Suppose any vector, because force is vector quantity, so if we want to take the component along any direction and angle is given, so we can write m the component of m1g along this direction will be m1g this, and what is the angle? 90, so cos 90, and as we know cos 90 is 0. So while calculating acceleration, we always make the force along the direction of acceleration and then calculate the net force. Now next problem. Next problem is there is table and at the both corner of table there is pulley connected and a string is passing over the pulley. Here a block of M2 is connected and here the block of M1 is connected. Here also a block of M is connected. Now again we have to find out acceleration, and again we are assuming there is no friction and there the total string is massless, so we can consider the tension along the throughout the string which will be same. Now as we know what is the process of finding acceleration, we know acceleration is net force upon net mass. Again there is no problem with mass. Net mass of the system is small m1 plus capital M plus small m1, sorry m2, but net. Again here one force m2g is acting in downward direction. Suppose in this problem m1 is greater than m2, so we can consider if m1 is greater than m2, then we can consider the acceleration is in direction along the bigger body, and for it this and for it. So again here m2g is in direction, m1g is in direction, here mg is in direction. Now when we write the total force, here since m1g is in the direction of acceleration, so there is no need to taking component, already the force is in the direction of acceleration, so we can write m1g. Here m2g is in the direction of acceleration, they are along the same line, so there is no need, again no need to taking component, but because it is in the opposite direction of acceleration, so we have to write minus m2g. Here mg is not, first mg is not along the direction of acceleration. So we have to take the component of mg along this direction. Since they are perpendicular, again 90, so component of mg along this direction will be mg cos 90, and cos 90 is 0, so this will be 0. So we can write acceleration is simply m1 minus m2 g upon m1 plus m2 plus m, right? Next question, suppose inclined plane and a block is kept on it and it is connected with a pulley, and on the another end here a block of mass m1 is connected, it is of m2 and this angle is. Now again, suppose m1 is greater than m2 and acceleration of the body of the system is like this. Now again we have to find out acceleration. As we know, acceleration is net force upon net mass. There is no problem with mass. Mass will be simply m1 plus m2, but force. And while calculating net force, force should be along the direction of acceleration. Here two forces are acting. One is m1g, because no friction, so we are not considering any friction or another force. And here m2g will be like this. Here, because m1g is already along the direction of acceleration, so we can write simply. Now again we have to find out the net force. Since here m1g is already along the direction of acceleration, so it is along the direction of acceleration and it is in the same direction of acceleration, so we can take it as plus mg. Now m2g, it is not in the direction of acceleration, so we have to take the component of m2g along the direction of acceleration. Since m2g is in downward direction, this will be 90 degree and this will be 90 minus theta, right? So if I make this triangle again, I can show the m2g force along this direction, and I want to take component of m2g along this direction. Why? Because acceleration is in this direction, so I want to take the component of force along the direction of acceleration. Now when we take the component, already we know this angle which is 90 minus theta. So component of m2g along this direction will be m2g cos of 90 minus theta. So cos 90 minus theta is sine theta. So we can write m2g sine theta, means the component of m2g along the direction of acceleration, this direction, it is m2g sine theta. So now we had made the component of force along the direction of acceleration, but it is in the opposite direction. So we can write here minus m1, m2g sine theta. So simply acceleration is m1 minus m2 sine theta g upon m1 plus m2. So while calculating acceleration, we always make the component of force along the direction of acceleration. If it is in the same direction, then we write it with the positive sign, and if it is in the negative direction of acceleration, then we write it with negative sign. Now next question. Suppose there is a system like this, two inclined plane, one is at beta angle and here this is alpha angle, and a pulley is connected at the top. Then the string, at the one end of this string a block of mass m2 is connected, and at the another end of a string a block of mass m1 is connected. Okay, now suppose m1 is greater than m2. Again we have to find out acceleration, and there is no frictional force, the string is massless. So we can write acceleration is as net force upon net mass. Again there is no problem with net mass of the system, it is simply m1 plus m2. But force, Here the force will be m2g, which will act in downward direction. Here the force m1g will act in downward direction. Now because m1 is greater than m2, so suppose acceleration of the system is in this direction. So if we want to calculate net force, so first we have to make the component of force along the direction of acceleration. Since here m1g is in this direction, so I want to make the component of force along this direction. Again this angle is alpha. This will be 90. Yeah, I'm redrawing this figure. This angle is alpha. This is m1g and this is 90. So this will be 90 minus alpha. And I have to make the component of m1g along this direction, and this will be simply m1g cos 90 minus alpha, and which can be written as m1g sine alpha. So component of m1g along this direction is m1g sine alpha. So here because m1g sine alpha is along the direction of acceleration and in the same direction, so plus m1g sine alpha. But here m2g is again not along the same direction of acceleration, so we have to make the component of m2g in this direction. So because it is beta, it is 90, so it will be 90 minus beta. So component of m2g along this direction will be m2g cos 90 minus beta, which will be sine beta. So here m2g, the component of m2g along the direction of acceleration is m2g sine beta, but in the opposite direction. So minus m2g sine beta. So net acceleration is m1g sine alpha minus m2 sine beta. G is common, m1 plus. So student, in next class we'll learn to find out acceleration, or to solve the another problem in which we'll consider frictional force. This was the problem in which we have ignored the frictional force and other forces. Okay, thank you.